All right, number 13. We're getting a little tricky here now. Now I'm going to infinity with a sign. Like, oh man, what's happening here? Let's think about this for a second. If x is going to infinity, then this x right here is becoming a super, super big number. So we have a big, big number. That's what he's becoming. And we're going to multiply that. X is going to infinity, then 1 over x is going to 0. And sine of 0 is 0. So we have a super big number minus something that's headed to 0. It doesn't never equal 0, but it's headed to 0. Well, a lot of times, I want to explain this because a lot of times kids are like, oh, well, 0 times anything is 0. Okay, yes, but here's the problem with this. This function, sine of 1 over x, never ever gets to 0. It's just headed to 0. So maybe it's super small, you know what I mean? Maybe it's getting really small, but this big number is getting super big. So if you multiply a super big number by a very tiny number, they don't necessarily have to go to 0. They might just approach some number in the middle. It really depends on, loosely speaking here, depends on which one's going faster. Does x get really, really big really fast? Does sine of 1 over x get really, really close to 0 really fast? Or are they kind of going at the same rate and they're going to cancel each other out? Now, really getting into all that stuff is L'Hopital's rule, and we're not going to go into that far at this point. But that's the basic idea here, is that x is getting really big, sine's getting really small, and either one of them wins or they tie each other. So we got to figure that out. And how we do that is, I'm going to rewrite this as sine of 1 over x over 1 over x. This is the same thing. Take a second look at that. Make sure this is the same thing. Divided by 1 over x is the same as multiplying by x. And now, check this out. As x goes to infinity, 1 over x is going to 0. But this 1 over x is going to 0. And what we can do here, I'm going to let 1 over x equal u. And what we end up with is sine of 1 over x has become u. The other 1 over x has become u. And now I don't want x to go, I want to know what u is doing. Well, if x is going to infinity, what's u doing? If x gets bigger and bigger and bigger, then 1 over that is going to 0. Well, as u goes to 0, sine of u over u is 1. But remember, I said this thing here is the same as this thing here. They're the same exact thing. I just did a little substitution. So if the bottom limit's going to 1, then this top limit's going to 1, which means our original limit has to go to 1.